Last video for today, we're looking at how do we actually find distance either on a number line or in the xy plane. So let's say I have 2 points. I'll call them A and B. So I'll have A over here at -2 and B here at 6. And I said find AB. Okay, well, many of you are probably thinking, well, I could just count. All right, 1, 2, blah, blah, blah. That's going to take some time, but I can do it. I will come up with the answer that AB equals an 8. Okay. Okay, well, let's look at another segment. How about put R over here, and I ask you to find RB. Okay, I can count. It's going to take even longer, but I can get the answer. It's going to be, once I'm done, at 12. Here's a quicker way to do that, though. To find A and B, or sorry, length AB, I can just look at this minus this. 8 is really the same as 6 minus -2. 12 is the same as 6 minus -6. So in general, on a number line, you're just going to do big minus small. Now, you can count spaces. I would just not recommend it because some of your number lines could go up to, like, I don't know, 150 or down as far as -3000. I don't want you to be sitting there all day putting a whole bunch of tick marks on your page and then having to count everything. So you can always do the big number minus the small one. Just make sure you keep those negatives on, and that'll always get you the right answer. Some other things that you're going to see, let me put another point about M, is you will get very confused with some of the notation that we're getting used to with those distances. They might say something like find AM plus AB minus, how about RB? Now these are numbers now, so I can come up with kind of anything. I know that each of them is positive, but I might get something that may be negative. I'm just bringing that out because this is asking us to evaluate something. It's not telling us to find the length of something. It's saying plug those lengths in. So AM, let's see, 0 minus -2 is 2. AB, we already found that one. That was 8. And then RB we found was 12. Okay. So we just plug in and use order of operations, PEMDAS, or please excuse my dear Aunt Sally. That'll get us a -2 when we're done. Also, another thing that will confuse people, they might tell you something like find 3MB. All that means is take the length of MB and multiply it by 3. So looking at our picture there, okay, so from M to B, that's 6 units. So that's going to be 3 times 6, and that's that. So number lines, pretty simple, not a whole lot to them. Gets a little bit more confusing though in the XY plane. So for the XY plane, or we call this also the Cartesian plane, let's say I have 2 points. I'm going to start here at 1, 1. And I'm going to move up to 4, 4. So I'm going to call this, I don't know, I want to use a different letter. You'll see why here in a second. How about MT? It's a mighty segment. So if I connect those, and they're saying find MT, that means find the length of that segment. Well, the thing is I can't really just count spaces because this diagonal is not the same length as this one right here. If I was to rotate this down, it's going to be a little bit longer. So I can't just count spaces. It doesn't work that way. Once you can have diagonals, now things get really tricky. You can't just count any spaces. Alright, let's see, did I want to put... Okay, I actually wanted to move this one more space. Totally messed that up. I wanted to make one of them there, and you scratch this one to make it work out nice and neat. You'll see why here in a minute. I'm actually going to move t over to here, and you'll see why here in a second. It'll give me a nice number when I'm done. Okay, so t is at the point 4, 5. M is at the point 1, 1. Okay, how am I going to do that? Well, I'm going to use a really old equation. C squared equals a squared plus b squared. This is called the Pythagorean theorem. Some of you are looking at that and going, yeah, I know Pythagorean theorem, but you only use that for right triangles. I don't see a triangle. I just see a segment. So what I'm going to do is construct a right triangle like so, and if I knew this length, I'll put a question mark here, then this length, a squared plus b squared equals c squared. A and b, those are just the legs of your right triangle. C is your hypotenuse. How would I find the length of this one? Well, here, that is just a horizontal distance. That's just like finding distance on a number line. 4 minus 1. Okay, 4 minus 1 is 3. And the length of this one, that's just another number line. It's just this number line is vertical instead of horizontal. 5 minus 1. Okay, so 4. So if I'm looking for this length from m to t, that's my hypotenuse. So using Pythagorean theorem, I'm going to say mt squared, that's just the length, it's a number, equals 3 squared plus 4 squared. Okay, so I have to square first. Mt squared, I don't know what that is, so I'll just leave it as is. It's the same as 9 plus 16. And so I can just take square roots on both sides. Okay, if this was a quadratic equation that we were solving, we would have to put plus or minus. This isn't really like a quadratic we've been working with, because mt is a length, and lengths are always positive. So whenever we're looking for lengths, we're never going to do that plus or minus. So what you can do to find points, or I should say the length of a segment in the xy plane, or the distance between points, you can just use Pythagorean theorem. Now let me show you a formula. It's going to scare some people, but it'll always work. It's one thing you can plug into and always get the same answer without having to draw a right triangle and without having to set up Pythagorean theorem. So I'm going to draw another triangle down here, and I'm going to call this point x1 comma y1, and this point x2 comma y2. So what I'm going to show you is something called the distance formula. The distance formula gives you the length of any segment in the xy plane. So what I'm going to assume is that these are points in the xy plane. So if I look at the x-axis, x1 is this x value, x2 is this x value. Now if I want to use Pythagorean theorem, I need to know the length of this bottom part. Okay, that's the same as when I found the length of this one here. I did bigger minus smaller. So I don't know what x1 or x2 is, but I do know that x2 is to the right, and so the length of this one is going to be x2 minus x1. That's the length of this segment right here. Okay, but I also need to know the length of this one. Well, I'm going to look at this vertical segment. This y value is y2. This y value, starting here, is y1. Up here, when I found the length of this side of my triangle, I did bigger minus smaller, just because I'm looking at a vertical number line. Same idea. And so to find the length of this segment, I can do bigger minus smaller. So this is one leg, this is the other leg. I know that's confusing, but it always works that way. Well, we haven't quite found the distance between those points. I'll call it d for distance. So all I need to do is use Pythagorean theorem. Pythagorean theorem would say distance squared equals leg squared plus leg squared. A squared plus b squared equals c squared. Same thing, it's just I'm using different letters because they represent coordinates in the xy plane. Now let's say I wanted to get just the d alone, then I could take square roots. So this right here is our distance formula. We are going to be using it this year, so we want to get used to it sooner rather than later. How is it going to work? Well, here's some examples. And again, you can use Pythagorean theorem. If you just love Pythagorean theorem and you love having to draw a picture every time, you can. And by picture, I mean a graph in the xy plane. But this distance formula will save you some time. So for example, let's say that I have the points 5, 1 and -2, 7. Instead of drawing an x-axis, a y-axis, making 5 tick marks, making 7 tick marks, blah, 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 these points, x1, y1, x2, y2, I can just plug right into this formula and it'll do all of that work for me. So what's that going to be? So square root, and by the way, it doesn't matter which one you call x1, y1, doesn't matter, because it's just like saying, do I want to find the distance going this direction or going this direction? Either way, you're going to find the same distance. So let's see here, the distance between those 2 points, 5, 1 and -2, 7, that's going to be -2 minus 5 squared, because it's x with x. Make sure you keep the x's together, and then make sure you keep the y's together. Biggest mistake students make on this is they kind of mix up their x's and y's. So that's x minus x. Now we need to do y minus y. And each difference we square. So this is the square root of -7 in parentheses squared plus 6 squared. You can put that in parentheses if you want, but there's no negative, so there's really no point in doing that. Okay, so you have to square before you square root. You cannot take the square root of this plus the square root of that. We talked about that last time. So that's going to be 49 plus 36. Remember, squaring a positive, a negative, you get positive. Well, let's see, that's going to be 85, square root of 85. Now, I don't know what that is off the top of my head. If you want to guesstimate, you can use your calculator. For now, we're going to leave all of our answers as radicals. If your radical does not come out to a whole number, then you just leave it as a radical. If it does, then use the whole number. Okay, so here's some other examples. I don't really want to work through because it's just the same thing over and over. I just want you to see how you plug into that distance formula. The last example I'll go through real quickly is how you can use that distance formula to find a missing coordinate. So this one's a little bit different. So here we know that we're working with coordinates in the xy plane because x comma y, x comma y. We know the length of A to B is 12, but we don't know what the coordinate of that one is. So you could draw yourself a picture, draw the x-axis, the y-axis, and kind of put the point 2, 9. The trick there is you don't really know where to put this one because you don't know which x value you're supposed to use. But we're going to use that distance formula. The distance, AB, equals the difference of x's squared plus the difference of y's squared. Also, I know AB is a 12, so I'm going to go ahead and plug that in. Four minus 9 is a -5. So if I square that, I get positive 25. Now, once we come to this is also a quadratic equation. To get rid of a radical, we can square both sides. Okay, and now you can FOIL out if you want to, but I think it's going to be a little bit easier to subtract off 25. If I take out 20, that's going to be 124. Take out 5. Let's see, that's going to be 119. Make sure I did everything right so far. X minus 2 all squared, yep. 4 minus 9 all squared, that's 25. 12 squared is 144. Alright, take away 25 from there. Yeah, right. 119. Okay. So from here we want to take the square root on both sides. Now that we're looking at coordinates, coordinates are positions in the xy plane. Those can be negative. So this is plus or minus. So this tells us give or take square root of 119 equals x minus 2. Add 2 on both sides, and x could either be 2 plus the square root of 119. X could also be 2 minus the square root of 119. So x could be either one of those. So just to recap, plugged into the distance formula, used some algebra to get that x alone, and that is our coordinate for the x position of B. That's it for today.